Hey everyone, today we'll talk about the Leetcode problem, generate parentheses. Let us begin. In this problem, we will generate a list of strings that contain n pairs of well-formed parentheses. In the brute force method, we will find all permutations of parentheses and see which one of them are valid. N is the number of pairs of parentheses, so length of the string of parentheses will be 2n. We define a list to hold valid answers. We use Q to grow the strings of parentheses. Let us first understand the function isValid. Consider the example of given p string. In the beginning, we define left unpaired as 0 and process characters of the given string one by one. First character is left parenthesis, so we increase left unpaired by 1. Next iteration makes it 2. And then we come across a right parenthesis, so left unpaired is reduced by 1. When unpaired left parenthesis becomes 0, it means that all of them are paired up. However, if it becomes less than 0 at any stage, we must return false immediately because a right parenthesis is present without a matching left parenthesis before it. At the end of the loop, there should be no parenthesis left unpaired. We return true if left unpaired is 0. If not, one of the two types of parenthesis is in excess and we return false. We now proceed with the main function. We store an empty string in the queue. In the while loop, we pop out a string from left side of the queue and save it in current string. When n is equal to 2, the final answer should have two pairs of parentheses with length 4. However, the current string length is not 4 as yet, so we skip the if statement. We append current string along with right parenthesis to the queue and again with the left parenthesis. In the next iteration of while loop, current string becomes right parenthesis. Its size is not 4, so we join current string with right parenthesis and append it to queue, and then left parenthesis. In the next iteration, current string becomes the left parenthesis, which gives these two new entries. Next current string gives two more entries, and then this gives these two entries. Next pop out gives these two new entries, and then these. All the 8 strings in the queue are of length 3 each. In the next cycle, we will get 16 strings each of length 4. Turn by turn, we will pop them out. Only 2 of these 16 which pass the test is valid are appended to the answer. After all of these are popped out, we return the answer that contains all of the valid strings of parentheses. There are 2n spaces that have two choices each, so there are 2 to power 2n total string permutations. Each string is 2n in length, so the processing of each string takes 2n time. Output space is for 2 to power 2n nodes of size 2n each. However, if output space is not included, space complexity is nth Catalan number, which is given here. We don't have to generate all permutations of the parentheses as most of them are invalid. We define answer to save final results. In recursive function backtracking, we will separately store the counts of left and right parentheses. We define current string to grow the string of parentheses and call backtracking with initial count of 0 for both the parentheses. Edge cases when size of current string is 2n and we save it to answer and the call ends. If count of left parenthesis is less than n, we add a left parenthesis and call the backtracking function with increased count of left parenthesis. We append another parenthesis to current string and make another call. Now left count is equal to n, so we skip the if statement and append right parenthesis this time and call backtracking. We repeat it once more. This time we reach the edge case, so we join the entries in the current string and append it to answer, and the call ends. We pop out the last entry and the call ends. In this call also, we pop out once more and the call ends. This time we pop out the left parenthesis and reach the next if statement. As right count is less than left count, we append 1 now and call backtracking now with counts 1 1. Left count is less than n, so we append one more of left parenthesis and make a call with parameters 2 1. It is not an edge case, but left count limit is reached, so we append the right parenthesis and make a call for 2 2, which is the edge case. We make another entry in answer. This call ends. We pop out from current string and another call ends. Next, we pop out left parenthesis. We skip next if because right count is not less than left count, and this call also ends. We make another pop out and this call also ends. Next, we pop out the left parenthesis. With left count 0, right parenthesis cannot be added. So we skip the if statement and all calls end. And we return the answer. Time complexity is given by Catalan number. Maximum size of current string is 2n, so space complexity is of the order of n. This time we will make the main function recursive and divide the problem into smaller size. Edge cases when n is 0. The answer is an empty string. We initialize answer as an empty list. Left count takes values from 0 to n minus 1. Initial value is 0. We make a call for n equal to 0, which is an edge case that returns an empty string. Left string gets empty string. Next, we make a call for n equal to 1, for which left count is 0. We make another call for n equal to 0, which is edge case that returns an empty string. Left string becomes empty string and makes a call for n equal to 0 that returns empty string, which becomes right string. Both left and right strings are empty, so we append a pair of parentheses in answer. The three for loops end and we return answer to the previous call that gives us the right string, and we append two parentheses to answer. In the next iteration, left count becomes 1, which calls function with n equal to 1. We remember that it will return a pair of parentheses, which becomes left string. Next call for n equal to 0 returns an empty string that becomes the value of right string, and we append another string to answer. All loops are over and we return answer to the final solution. If we consider n equal to 3, left count gets values 0, 1 and 2. For 0 value, left string choice is empty string, while right string has two choices. This gives two entries to answer. For left count equal to 1, we get one more entry to answer. Left count 2 gives two more entries. These 5 strings give the complete answer for n equal to 3. All these results will be used for n greater than 3. Time complexity is Catalan number. Space complexity is of the order of n. Thank you for your time. I hope you enjoyed the video. Please stay tuned for more such videos.